Okay, I think you start already. Um, yeah, I see. Okay, at least I see some microphone going up here. So, guys, welcome back to my vlog. And so today I actually think about making an create an LXD profile. Okay. So I mean, just we just work. If you know you run some LC list, you can see there's a machine is running, but it's not being assigned any IP addresses. So what I probably do is, remove this machine and then have to take a look on all the network I have. So throughout this video, I will just focus mostly around this YAML file here. So you see that I try to specify some kind of network here, but it probably not work that smoothly. And when I go back to the previous, okay, I need to open a new window for this. And yeah, so around the place, I would say yeah, I'm not talking about the farm for now. I was mostly talking about set up an LXD. And one of the challenges that I facing right now is, basically I'm trying to uh, I'm not sure why I produce this with me. I was yeah, I think I was working more on KVM. I have to successful in terms of KVM and stuff. But then when I try to use KVM, I have some LSD in specific. I have success. I have some success in it. So probably what I was missing is correct network configuration. So Yeah, so the idea is that I need to be able to forward the traffic um, from all the machine in the same network as of the virtual machine, right? To be able to, I want to communicate to be able to reach to the IP addresses directly, to the VM IP address directly. So I don't really want to use any overlay network. That's the part, right? So I was looking at the map VLAN things. So I don't really want to do any nothing and things like that. Yeah, so for most of the things I see here is IPv4 addresses, and we can disable DHCP with, because from what I know and recall, the DHCP is the LXD will install the DNS DNS, the old DNS server, DNS MAQ. So I think we can just disable that. I haven't tried to configure this, so, but I do curious if this is possible. When I'm talking about creating the bridge, I think I used to work on that, and I think I do document that somewhere. Yeah, I just simply use bridge network by default, and then I have the net plan, something like this. Interesting. Okay, I have never thought that I had this thing set up before. And with this thing set up, then I can probably create an LSD profile, something like this. I pretty sure this is for the virtual machine or something. But obviously the virtual machine will be created via OpenStack Terraform, sorry, via Mass Terraform. So I don't really want to use any CLI in that case. But I do need the CLI to, you know, set up the network, net plan, create a network plan, LSD plan. So you disable most of the stuff here except for the ATSO, but ETS1 we will have this kind of thing. So I can remove the LXD, initiate it again, and creating a network. Disable the DSP or the bridge, and then launch the image. So for the device, okay, so the profile is, when we're talking about profile, we're talking about yeah, that is some good stuff there. I think I can probably just follow this thing and make it work for me. Well, let's just fully follow this tutorial for now, and we will see how it's work. There's one thing I'm not sure about. Maybe I just run the first two first, and then I can start working on all the things. You know, most of the food at night is very unhealthy. Uh, we don't have any real food that I can eat, so well, there's chicken. I think I can eat chicken. Or maybe I can just not eat anything because I have been eating plenty during the day, so you know I won't getting too fat now because being fat is very unhealthy. So, anyways, one other thing I would do is let me just close this archive doing thing for now. Well, I do have the storage spoon. I have the profile here. So there's some modification that I might want to do. Okay, I was thinking about the parent bridge network. Is that the bridge network being created from the first, Yeah, I do have a bridge network here. Okay, interesting. Interesting to me, I would say. Yeah, I do need to create a bridge network for the VMs so it can connect to and use that as a way to communicate with. So I think most of the step will be around line 9 to line 7 9. So I think we can just take advantage of these guys, and we do have a net plan here as well. The net plan might be helpful for us to actually, to actually. Yeah, so you know what? Um, let's just go with this solution. I would say. So one other thing I would do before I do anything else is removing all the redundant subnet here. You know, we don't want trash on our console. You know. This is a Docker network, I think. Yeah. So we can remove that later. So anyways, I think I can just go to the machine here. Go to one of the machine I have. For example, we can try with the RS because that is my newest machine, I would say. So from this address, you can just access to it. Okay. Simply want to press and I'll just make a quick update and upgrade things, and then can start from creating the bridge network. Okay. If you want to understand what is a bridge network, I think we can try to understand it from, to do all of these DevOps things, you actually need to be really understand on how the operating system, the operator machine, and stuff. For me, I don't think that I should configure network forward in this layer of virtual machine. I mean, it's good to know that I can use one physical machine and then forward the traffic to all the virtual machine. I don't think I should do that. I would continue making that work on container layers using software like Nginx and for reverse proxy things like that. So I don't really think that I need to use this for future.
Hello, I'm Stefan Greber. I'm the project leader for LXD, and today I'd like to talk about networking. LXD supports many networking options, from a simple local bridge to device pass-through, MAC VLAN, peer-to-peer connections, IP VLAN, routed network interfaces, SRIOV, or even a full-on SDN like Oven. For the vast majority of people running individual systems, a local isolated bridge, like the one you get just by running LXDNS, is perfectly fine and will do the job just perfectly. Um, for multiple systems, things get a bit different. For multiple systems that happen to be sharing the same physical network and where you're in charge of the network infrastructure, then quite often the easiest is to actually put your instances directly onto that physical network or on a separate VLAN on that physical network. And for that, you can use interface pass-through, a OS level bridge, MAC VLAN, OS IOV. all of those options will work perfectly, and that will get you the best experience for that. But then you've got a situation of having multiple systems that may or may not share the same physical network, or maybe you don't have access to reconfigure the network, or you don't control the gateway. Then you've got kind of two options for that. One is to use Oven, and the other is to use something called the Ubuntu fan. And the Ubuntu fan will be the focus of this video. Now, as I said, the other option would be using Oven, but Oven, while very, very flexible, also means it gets quite complicated to set up at times. It's got a lot of advanced features, but you're gonna need to run effectively a database that stores its state, that next integrates with that and configures it, and there's a bunch of dynamic tunnels, and it's great if you're running an actual production cluster, for example. It's perfectly fine to deploy for that. But if you're just messing with a few systems at home, or if you're deploying a small legacy deployment, whether it's clustered or not, in the cloud, then there are easier options, and the Ubuntu fan is that easier option in this case. So, what's the Ubuntu fan? Well, the Ubuntu fan is effectively an overlay network that's built into the Ubuntu kernel. This is not a mainline Linux feature, so if you're not using the Ubuntu kernel, it's going to be missing. But for those using the Ubuntu kernel, the Ubuntu fan is effectively a way of having like a stateless SDN in many ways. So by reusing some normally unused address space, it's possible for a machine, either 250 machines, to have up to 16,000 containers each, or up to 16,000 machines to have 250 containers each. That the way the fan works, it effectively encodes the machine's address within the instance address, so that the Linux kernel can figure out where the destination is and just send the traffic tunnels to that target machine. It's really quite clever, works really well, and we're going to be looking into this today. So what you're looking at here is the mass deployment that we use on the LXD team. I selected 3 Raspberry Pis. They're all deployed now with Ubuntu 20.04. They're all technically on the same network, so I could actually use some other networking options, but I'm not gonna in this case. And the goal here is gonna be to assemble a quick LXD cluster on those, show how LXD automatically sets up fan networking for new clusters, and then show how to attach another system that is not part of that cluster to the same fan overlay effectively, so that its own instances can interact with the instances running on those 3 Raspberry Pi systems. So I'm just going to be switching over here to now LXD comes pre-installed with Ubuntu 20.04. I'm just going to be refreshing that over to the latest.
Yeah. This guy definitely know what he's talking about.
Release of LXD, so they all run 419 that way. So copy paste that to all 3 of them, and give them a few seconds to download and update. Once that's done, which should be very soon. Starting. Okay. Just gonna run LXD init on the first one. Need to zoom onto that one here. So I'm gonna be using clustering. Using its IP is fine. I'm gonna be creating a new cluster. It's called alpha01. No need to set up password authentication for the cluster. Just gonna be using joint tokens instead. Sure, a local pool using ZFS is perfectly fine. using a dedicated partition. 30 gigs is plenty for this use case. No remote use. Switch the new fan overlay bridge. Underlay live. They all happen to be on the same subnet. My laptop is not. Leave it to it's detected that we are on Ubuntu and the kernel supports it, and therefore leave it to auto. What it's going to be using in this case would be this, I believe, be on this. And while it would work for all three Raspberry Pis because they all happen to be on the same subnet, my laptop is not on that particular subnet. So I just need to widen the subnet a tiny bit to using this instead. By doing that, I effectively now limit the number of instances I can run per system. With the /24, as it would have done automatically, each one of the Raspberry Pis would have been able to run 16,000 containers, whereas by using a /16 for the network side of things, then they are gonna each be limited to 254. That's not really an issue, and I'm gonna be running more than that anyway, but just something to keep in mind. The rest, just using the default cluster is initialized, and now I just need to cluster add R502 and R503. That's their joint tokens, and I'm gonna be running LXD init. Both of those. A few seconds to go. Yes, this is fine. The existing cluster and the giant token. And just using the defaults for everything. Go. Yeah. Wait. When you're on the first cluster members, it's gonna land on R501. Once that's done, I'll do the same 2 more times so that we get a container on each one of the Raspberry Pis. The first one is good. Second one must be from first one. We'll start. Simply with the 0/8 as the default subnet. And now if you look at the middle of the address, you'll see how the fan works. So U1 here is running on RPi01. RPi01 has IP address 172.17.16.8. Now, the mask we entered earlier meant that 172.17 is the local network, and then the rest of the address is the host identifier. Which means that if we look here, we see 240.16.8.108. The 16.8 in the middle is the same 16.8 we have here. And that's how the fan knows where to route the traffic. And we can see this one is running on the second one, so it's got 16.7. This one is running on the third one, it's got 16.19. And that lines up with that 16.7 here and 16.19. So now if we go in the first one and ping the second one, this just works. It effectively sends the traffic onto its host, so in this case RPi01. RPi01 extracts the target address from the IP address being reached, and then sends the traffic encapsulated to that particular system, which then forwards it onto the destination container. So that works really well. In this case, it's all within one cluster, so all the instances can talk to each other, it's fine. The issue is if you're coming from an external system, say my desktop here, and I ping this, it has no idea how to go to it because this is effectively an overlay network and you're not part of the overlay. So there's no super good answer to that. You can manually configure that system to join the fan. That's one way to do it, and you can access those instances. Or most likely what most people do is that they will add a proxy device to the instance to actually forward traffic going onto the host, in this case RPi01, onto onto a given port of the instance. But in this case, what I'd like to show is how you can add a completely standalone LXD, so in this case my desktop machine, to the exact same fan network, and then the instances running both on my desktop and on that RPi cluster will be able to talk to each other. So for that, you need to create a new network. Let's call it 1BR0. it's the type is a bridge, but that's the default. It's what we need is bridge mode equals fan, and then fan dot underlay network, I believe is the name. Then sets that to the same value. Actually, I can just check what's used here on the Raspberry Pi cluster.
So hot.
Fan underlay subnet is the key. So fan underlay subnet and 172.17.00/16. Okay, so now I've got a bridge here. So if I launch, let's just do initially just launch a quick VM. So that one is going to be on the default network, so it's not going to be able to talk to the fan. Well, it needs time, a bit of time to boot up, but let's already start the second one. So the second one I put in B2, and that one I'm going to ask LXD to place it on the fan BR0 instead. Let's zoom in that terminal. Okay, so the first VM has started, and we can see it's got a 172.17.250 combitium related address. That's actually going to be reachable from the Raspberry Pi cluster because that's routed on my local network. There's definitely an address directly from my home network, but this would not be able to reach into the Raspberry Pis because it's not on that 240 subnet and has no way to get there. However, if you look at V2, we can see that that one is on a 240 address. And in this case, it's on 240.250.1.115, which, based on what I said earlier, means that my host system is reachable at 172.17.251. Now, if I try to reach the Raspberry Pis, well, when it is on Raspberry Pis, this works just fine. And similarly, if I go in one of the Raspberry Pi instances up here, and I get the IP address of that VM on my laptop, or on my desktop, it also works just fine. So this really shows how to easily have multiple, even independent LXD deployments, still be able to route to each other and have instances just effectively on the same network. One reason why this is particularly useful is if you're on Wi-Fi, you can't, like the way Wi-Fi authentication works means you can't bridge it, you can't do MAC-VLAN, you can't do any of those things. The only way you're gonna get two systems on Wi-Fi to actually have instances that can talk to each other, actually, I can find it more than 32 actually, is either running a full-fledged SDN like Oven, or using something like the fan, and that will work just fine. Hello, I'm Stephen Kreber, I'm the project leader for LXD, and today the physical NIC into it, and the physical NIC itself down here doesn't have much in the way of config at all. So the result is effectively this, which is BR0 here, physical NIC here, which has BR0 set at its master. And if we look at the IP addresses, we only have IP addresses on BR0 and on LXD BR0. There's nothing on the physical NIC itself. If you get such a setup working for you, then that makes your life quite a bit easier with LXD because you can again start the instance. Okay, start again. Let's just go and edit this config directly. And here, instead of using MAC-VLAN, you can just say it's bridged. The parent BR0 is the bridge, so good. Save it. Start it back up, and we'll see it behaving pretty much identically to MAC-VLAN, but with one pretty significant change in behavior. So it's running, start the loop, so it's connected from my desktop just fine. But now let's try from here, and now it works. So a bridge works both externally and internally, so you can actually connect from the host to the guest just fine if you've got a bridge in place. As I said, the downsides to a bridge compared to MAC VLAN is that you need to potentially reconfigure your entire system's networking to be applied to a bridge rather than your normal physical NIC. And that can be quite annoying to do, especially because it's very distro dependent. So that's for your normal options as far as just getting traffic from the outside into, like, directly routed or directly routed to the instance. Now, none of that would work if you're dealing with a cloud instance, for example, or an environment like that where you can't just route across the internet, or where you might not have multiple addresses or a subnet or something that you can put your instances on. In such cases, you're gonna go back to the initial behavior, which I'm gonna make happen now. So I'm just gonna remove the tier0 override, start it back up. So it's gonna move the instance back onto XDBR0. There we go. I'm gonna go onto my router and I'm gonna delete the route that I added. Okay. And I'm just gonna make sure that I can't reach that network at all from my machine. Okay. And then let's go into the instance, start netcat again. Just make sure it works fine by connecting from the host system to the guest. It's fine. Now, how do we expose that? So say the only IP address that you have is the address of the host system. So in this case of the Raspberry Pi, that would be your only publicly reachable IP address. So now let's say we want that particular instance to be reachable. Like if you reach this IP address on, say, port 1234, it reaches the instance on port 1234. The first option is effectively to do NAT, and you could do that manually directly with IP tables and make it such that reaching 1234 on that IP address here gets forwarded to the internal address of the instance. Or you can have LXD do it for you. I know my preference, but in this case, what we should start doing is stop the instance and place a device override on one. And we're going to be setting a static address through the HCP to make NAT easier. So let's say we give it 200, then start U1, and it should be taking that IP address. There we go. Now the next step, so I'm going to put the netcat in place again. What we want to get is that I should be able to connect from my computer to this IP address on 1234, and it should connect to the instance. Currently it doesn't, but let's make it work that way. So we're going to be adding a new device to the instance. Let's call it 3W. The type is proxy, and then we need to set up what address to listen on, which in this case is going to be TCP. The IP address is 172.168.13.49, port is 1234, and we want that to connect to the IP address inside. I don't remember if that works with NAT, but I guess we'll find out soon enough. And there's an option to just do plain NAT. Okay. And this works. So now LXD has effectively put a NAT rule in place on the host that just forwards straight to the instance, and it works perfectly fine. There is one option, so that uses NAT. The downsides to using this approach is you need to have the static address. It also relies on the fact that the host, in this case the Raspberry Pi instance, and gonna be replacing its default ETH0 coming from the default profile with the different one. So option number 2 would be using like do it there, depends completely on the vendor. So I've got netcat listening on port 1234, and currently the instance is running on that IP address on the LXD bridge. So I can connect now on the client. This will work just fine. I'm connecting from the Raspberry Pi to the service running inside an instance on that same Raspberry Pi. That works fine. That's not very useful in many cases, because unless the Raspberry Pi happens to be your main system that you're accessing stuff from, that won't do you much good. But that's what works out of the box. Okay, get cancel that, and just start the netcat again. For good measure, I'm just gonna put it in a loop, so we don't need to keep restarting it. Okay. So now if I try from my own machine, so here, and I want to, let's do the netcat, I just want to access that address. Well, that's not gonna work, obviously. That subnet does not exist on my machine. It is nowhere near accessible from here, so I just can't get it. The first option that you can do is, if you control your router, so if you can go, and how to exactly do it there depends completely on the vendor. If you can go in your router and you can add a route for this subnet here, so the LXDBR0 subnet, the route through the machine that is hosting those LXD containers, then things will pretty much just work. So I can try doing that first. So I need this subnet to route through this address. Let's go on my router to this address.
And I need to do some more study, guys. This guy is the master. He made it so simple. I need to take a break now and maybe continue on this tomorrow or something like that.